Section 8.2 Quartic Graphs. A quartic function has the form f of x equals, or it could be y equals, something times x to the power 4, and then possibly an x cubed, x squared, x, and constant terms. So a, b, c, d, and e here are real numbers. That does not mean they are whole numbers. That's not what it says. Real numbers are any number you could put on a number line. Positive, negative, 0, all the decimals in between, never-ending decimals as well. Absolutely any number you could put on a number line. So any number you've met in your maths education so far. A is not 0, because if A was 0, then it would not be a quartic anymore. So A, B, C, D, E could be any number. The only restriction is A is definitely not 0. Now you need to be able to sketch the graph of a quartic function, and they can take several different forms. It's a little bit trickier than a cubic, not much, but slightly trickier, and it depends on the exact nature of the function. If we look at these two on the left, in both these cases, A is positive. A is the number in front of x to the power 4. So when A is positive, the beginning and the end of the graph, the sections that head up to infinity, they go up to positive infinity. Yeah, these graphs don't just suddenly stop. They keep going forever. And when A is positive, the two ends point up to positive infinity. Let's contrast that with when A is negative. So here, this is an example when A is negative. When A is negative, the two ends of the graph head down to negative infinity. Let me draw your attention to this first graph. This is basically what the basic x to the power 4 graph looks like. It's a bit like the x squared graph, but just a bit flatter around the middle, around the origin. So note there's one turning point here, there's one minimum point, that's it. But we could get 3 turning points, 1, 2, 3, and that is the most we can get. I'm just going to add that to your notes. I recommend you do the same. So at most 3 turning points. It could be fewer than 3, but there will never be more than 3. If we look at the one on the right hand side, here we have an example of a repeated root. Similar to cubic graphs, when we have a repeated root, it bounces off the x-axis. In other words, we get a stationary point. So this point here on the graph, it's bouncing off the x-axis. So that tells us we have a repeated root. Every time we have a root, it goes through the x-axis, and when we have a repeated one, that's almost as though it's started to go through the x-axis, but it's immediately turned around and come back the other way.